Therefore, I have my G, which is -1, F, which is 2/3, and my C, which is -4/3. So with G, F, and C, I would like to find the center. Initially, my center, which is -G minus F, is given as -G and -F, that is 1 and -2/3 is the center for the given circle. And next is finding the radius, where I need to find with the formula root of G square plus F square minus C, that is G square plus F square minus C is what we get. So this, on further simplification, gives root of 1 plus 4/9 plus 4/3, which on LCM gives on root whole of 9 and 9 plus 4 plus 12, that is 4 times of 3, which is the LCM. So this comes as 25/9, which is 5/3 is the radius, and 1 minus 2/3 is the center. So the center and radius of the circle in general form is how we obtain using the two basic formulae, this and this. Unit circle is one of the type of circle which we're going to discuss now. So what do we mean by unit circle? The word unit means 1, indicates to 1. Therefore, I understand that a unit circle is a circle with radius 1 unit. So therefore, if the radius is 1 unit, then that circle is called unit circle. Say for example, if I take a circle with center as origin and the radius is 1 unit, then in this case of radius being 1 unit and center as origin, I have my equation of circle given by x squared plus y squared equal to 1 is called the equation of unit circle with center as origin. With center origin is how we understand the unit circle x squared plus y squared equal to 1. Now next is the point circle. So what do you mean by a point circle? Before we discuss about the point circle, let's come with a revisit on circles. Now as I see, a circle with radius r is reducing to a smaller circle with smaller radius r2, and then again reducing to a more further smaller circle, say with radius r3, and so on and so forth. It reduces almost, when it reduces with radius, it almost diminishes to reduce to one single point. So this bigger circle has become smaller with reducing of radius, and more reduction of radius, more smaller circle, more smaller and more smaller. Finally, we end up with a point when the radius is almost 0. Therefore, radius equals to 0 units implies the circle is called point circle, because when the radius is 0, the circle diminishes to a point. Therefore, for this radius equal to 0, we call this as a point circle. Is how we understand in mathematics. Therefore, in order to define a point circle is a circle with radius equals 0 units, is how we understand. So what is the equation of point circle with center origin? Say I want to find point circle with center 0, 0 is given by x square plus y square equals 0. There is no constant out there, is how we understand this. Now, interestingly, in this case that we have defined the point circle is the point itself, we can also say that the point itself is the circle and the point itself is the center of the circle. So, here I conclude that point circle is the point itself, or it is the center itself, is how we understand with radius equal to 0. Now what happens if I take my center as hk? If my center is hk, that implies my point circle is given by equation x minus h whole squared plus y minus k whole squared equal to 0 square, is what we get as the point circle with a center h, k. For example, I have a circle, say x squared plus y squared minus 4x minus 6y plus 13 equal to 0. Then in this case, let's see if this is a point circle. Now in this case, I clearly have my g is minus 2 and my f is minus 3 and my c is 13 as compared with x square plus y square plus 2gx plus 2fy plus c equal to 0. Now in this case, the radius, which is given by the formula root of g square plus f square minus c, is g square plus f square minus c, which on simplification gives 4 plus 9 minus 13, which is equal to 0. Therefore, radius equal to 0, and this is called point circle. Now this with radius 0 implies the circle is a point circle, a circle with radius equal to 0 units, reduces to a point, and that point is called a point circle with least radius. Now let's see the equation of circle passing through origin. Say I have a circle which is passing through origin. If this circle is passing through origin, then we have equation of this circle as s x square plus y square plus 2gx plus 2fy equal to 0. Now this makes us understand that whenever a circle passes through origin, the c will be equal to 0. So the constant c in the general equation of circle is vanishing, because when a circle passes through origin, we have c equal to 0 always, and therefore the equation is x square plus y squared plus 2gx plus 2fy equal to 0. The next case here is where the circle is exactly with its center on x-axis. So what would be the equation of circle with center on x-axis? Say I have my x-axis, my y-axis, and with center on x-axis. Let's see if my y coordinate would be 0, because when the center is minus g minus f, the f reduces to 0, and therefore when center is on x-axis, minus f equal to 0, that implies f is 0, and therefore with this f equal to 0, I get my equation of circle as x squared plus y squared plus 2gx plus 2fy, which vanishes because f is 0, and therefore I get the equation of circle with center on x-axis is s equals x squared plus y squared plus 2gx plus c equal to 0. Similarly, let's see what would be the equation of circle with center on y-axis. Now in this case, I have my x, my y-axis, my origin here, and the circle is exactly with its center on y-axis. Therefore its x coordinate is 0, therefore minus g minus f reduces to 0 comma minus f, and therefore we have here minus g equal to 0, that implies g equal to 0, which defines the equation of circle, where s is x squared plus y squared plus 2fy plus c equal to 0. G equal to 0, therefore 2gx, the whole term vanishes because g is 0, will be the equation of circle with center on y-axis. Is how we understand the special cases of the circle with center on x-axis and center on y-axis with the respective equations derived. Concentric circles. What do we mean by concentric circles? The circles which have the same center are called concentric circles. Say for example, I have a circle with center this. I have one more circle with same center. I have another circle which is of the same center, and so on and so forth. So each of these are said to be concentric because they have the same center. That's how we understand the concentric circles. Now here, let me say the equation of this circle is s is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Then the equation of any other concentric circle, say for this, will be, say I take this which is concentric with this, is 1, 3 and 4. So the circle 3 which is concentric with this is given by s dash, that is x squared plus y squared plus 2gx 2fy plus c dash equal to 0. So when two circles are concentric, they differ only with the constant. The rest of them are same because the center does not change. The center being minus g minus f is fixed for any circle which is concentric. The only thing which changes is the constant c, and hence when two circles are concentric, they have only the constants which are different. G and f is the same. That's how we understand the two circles being concentric to each other. Now for the circle, we have x-intercept and y-intercept. Just like a straight line has x-intercept and the y-intercept when taken in xy coordinate system. Similarly, a circle which cuts x-axis makes an intercept which is called x-intercept, or a circle if it cuts y-axis makes a y-intercept, is how we understand. Therefore, let's see how we can find the x-intercept for a circle. So, for example, I have a circle say this. Now here, this circle with center as minus g minus f is cutting the x-axis at 2 points A and B. Now this is called the x-intercept of this. Say my circle is x squared plus y squared plus 2gx plus 2fy plus c equal to 0 in its general form. Then x-intercept is clearly the distance AB, which is given by 2 root g square minus c units. That's how we understand the x-intercept, which is 2 root g square minus c units. Similarly, we have the y-intercepts, which are going to discuss in the next section. Similarly, let's see what would be the y-intercept for the circle. So, for example, I take x-axis, y-axis and origin where my center is minus g minus f, and it is making an intercept on y-axis, which is this. So let's see, for an equation of circle which is in general form as equal to 0, I have the y-intercept, which is given by the distance AB, which is nothing but 2 root f square minus c units, is how we understand the y-intercept made by the circle on y-axis and the x-intercept also made by the circle on x-axis. The x-intercept and y-intercept have their own respective formulae. So let's take a special case where a circle touches x-axis. Then under the condition, let's see where I have x-axis and y-axis and where the circle is touching x-axis, where the center is minus g minus f and it is touching here at on x-axis at P. Now clearly I see that the coordinates of P are minus g comma 0 because the distance which it makes here is same as what it makes here. So x coordinate is minus g comma 0 is the point where the circle is touching x-axis. So when a circle touches x-axis, then we have the condition this, which is obtained from the intercept, because my intercept is 2 root g square minus c, which reduces to 0 when this tends to touch, and this on simplification gives this equal to this. This is how we obtain the condition for touching the circle touching x-axis, g square equal to c when the circle touches x-axis. Similarly, let's see what happens when the circle touches y-axis. That is, if I have my x-axis my y-axis and origin where the circle is touching y-axis here. Then in this case, I have clearly 2 root f square minus c, which is the y-intercept, tends to 0 because this touches only when the intercept reduces to 0 dimension. So this gives me this equal to 0 where my f square equal to c is the condition when the circle touches y-axis. Touching x-axis, g square equal to c, and touching y-axis, f square equal to c. Secant of a circle. So what do we mean by secant of a circle is what we're going to discuss in the session. Say for example, I have a circle in the xy coordinate system. Now there's a line which cuts the circle. There's a ray which cuts the circle at points A and B. Now L is called the secant of the circle because the line which cuts this circle is called secant. So this is called secant for the circle as considered here. So we need to understand that when a circle cuts, it always cuts at 2 points at the most, and therefore when a secant exists for a circle, there are 2 points which are the points of intersection of the secant and the circle. Here A and B are the points of intersection, and this gives a line segment which we're going to discuss with a new property in the continued session. A secant is the line which cuts the circle, any given circle is how we understand.